Okay, so everyone should have received a piece of paper with systems. There's 3 types of solutions you can run into. Looking at this first picture, our lines are crossing each other. They cross at just one point. So they cross at one point. That is our one solution. So if your lines touch at one point, there is one solution to your system of equations, and just one. What do you notice about that second example? They're parallel. They're never going to touch. They're never going to cross each other. So if your lines are parallel to each other, we don't have any solutions. And what do you notice about that last one? The lines are right on top of each other. They're the same line. So any point on that line works. So that is infinite solutions. So these are the 3 types of situations you might run into. You might have one solution, there might not be an answer, or you might have an infinite number of solutions. So any point works along that line. And so we're gonna using this graphing is pretty helpful with being able to determine what the answer is. We'll talk about when we start using the equations how to determine whether there's one solution, no solution, or infinite solution. But with graphing, if they cross at a point, it's 1. If they don't touch, it's none. And if they're on top of each other, it's infinite. So, what I mentioned earlier though, your system or your solution has to make both equations true. It can't just be true for one, it can't just be true for the other. It has to work for both simultaneously. So if we're to check if a solution or if a point is correct, we have to check in both equations that it works, in both equations that it's true. So we have to take that x and y and plug it into the x and y in both equations and make sure it's correct for both. So if we did it on this first one, we're going to take 8, plug it in for our x, and 1, plug it in for our y, and see if that works. So I'm going to put it in for both of these equations. Does it? So let's see. 8 plus 1, does that equal 9? Yes. So that one is true. But I need to check for both. So 2 times 8 minus 5 times 1. I want to check if this equals 11. 2 times 8 is 16. 5 times 1 is 5. Is 16 minus 5 equal 11? Yes, it does. So because it works for both equations, it is true. If it doesn't work for one of them, or it doesn't work for both of them, it is no longer true. It is not a solution. You probably have. You might have been introduced to this in the past. You probably actually got introduced to system of equations a little bit on simple system of equations last year with Frank. So see if you can check that other one. See if that other one is true. Plug it x and y into both your x's and y's in both of the equations. Check both of them. If it works for both, then it's good. If one doesn't work, it's not good. Take a moment. Try that. All right. So 2, 0. Was this a solution?
Yeah. No.
Why not?
No, because. Yeah.
So if we plug 2, 0 into our first equation, we get 0 equals 2 minus 2. That one checked out. That one works. But if we plug it into our second one, we get 0 equals negative 3 times 2 plus 4. That gives us negative 6 plus 4. And this is 0 equals negative 2. That is not correct. And so it is not a solution to both of these, so it is no longer a solution for our system. So whenever we find your solutions, it's always beneficial to check. It's always beneficial to go back, plug it into both of them, make sure it works. Sometimes it will, sometimes it won't, and if it doesn't, you need to go back, because you probably messed up somewhere in that math. So it's always beneficial to check your answers. So, thinking through yesterday. Let's listen up. So thinking through yesterday, we learned one of the methods to solving a system of equations was using a table. I believe that was the method that every table or every group showed yesterday. So you can use a table to help you solve for your system of equations. So we have y equals x minus 3, and we have y equals 2x plus 9. So you can just create a table and start filling in these values and look for when both of these values are true, or when both of them are the same. So plugging in 1 for x, 1 minus 3 is negative 2. Plug in 2 for x, negative 1. 3 gives you 0. 4 gives you 1. 5 gives you 2. You can do the same thing on the second one. Plug in 1. 1 times negative 2 is negative 2. Plus 9 is 7. See if you can fill out the rest of the table. See if you can find where is the solution based off of this table. Or is there a solution based off of this table? So let's fill in, what did you find for the rest of this table? What was 5, 3, 1,
Negative 1.
negative 1. Alright. Now that we have both these tables, we need to check what solution was true for both of them. What number did you plug in to get the same answer for both?
Yeah, 1. Oh, that's where I got all the answers. 1. Oh, Joe, you got it wrong.
So if we plug in 4 for both equations, we got 1 as our answer for both. So it needs to have the same x and the same y, because remember, it has to be the same 2 points. It's an x, y for a solution. So the solution for this system would be 4, 1. What's the x? What's the y? Ashton, are we paying attention?
No.
I would put that away for now, please. All right, so a table is one way to solve these. Listen up, please. A table is one way to solve this. But if those tables don't get to your correct answer until like 54 or 78, it's going to take a long time to fill out that table. So rather than do a table, one solution or one better option could be to create a graph. Yes.
Would you just find the slopes of the line with it?
Yes. So like we saw in that example earlier, in order to find the solution of the system of equations by graphing, we just need to see where do those graphs or where do those lines touch each other. So we'll plot both of them and just look for where they're touching. So the main thing you really need to know for this is just how to graph these lines. So we're just thinking back to graphing before that we learned before. So looking at these lines, these are in slope-intercept form. Y equals mx plus b. So the first thing I always need to do, what is my y-intercept? So looking at my first graph, or my first line, what is my y-intercept for that one? Actually, 3. My y-intercept.
Wait, no, for the first one?
For the first one.
4.
Negative 4.
Yes.
So it's a minus. So that means I need to plot negative 4 on my y-axis. Now, what is the slope for that first graph, or that first line? Actually,
3.
3. So because my slope is 3, that means every time I go over one space, I have to go up 3 spaces. So over 1, up 3. Over 1, up 3. 1, up 3. And that is my first line. My y equals 3x minus 4. I just need to do the same thing for the second one and see where they touch. So my slope for my first, or my y-intercept for my first one is at 3. So plot 3. Now the slope is negative 1/2. That means I go down 1 over 3, or over 2, I'm sorry. Destiny, Gabby. So I'm going to go down 1 over 2, down 1 over 2, and keep doing that for the rest of my line. I can do the same thing backwards. So what would be the solution to this graph?
Where the edge, where the lines touch.
Where they touch. So
Your intersection point at 2, 2, 2.
2, 2 is my solution.
But I don't
Once again, in order to check, just to make sure this is correct, you can take 2, 2, plug it in for your x and your y, and check on both of those. If it works for both of them, then you know you graphed your lines correctly and you know your answer is correct. Are we okay with this? What do you know is different about that next example? What is different about this next one? What was that? What type of form are these lines in?
We were in the main part. They're b, it's mx minus mx plus b.
That's your slope-intercept form. So these are in standard form. So one thing that we need to know, what's the difference between graphing in standard form and graphing in slope-intercept form? We need to remember the difference. We need to remember how to graph. How do we graph standard form? What do we do differently? Why?
You have to like get the line so we gotta
So with standard form, we were using that cover-up method. So I'd cover up one of the numbers, either my x or my y, and I'd solve for the other one. Then I'd plot that as my intercept. So if I cover up x, I have negative 3y equals 12. From here, we just divided. My y was negative 4. So I plot negative 4. Same thing for your x. I cover up my y, so I have 2x equals 12. Divide by 2, x equals 6. But once you got both those points, we couldn't just draw the line necessarily. We need to make an accurate line if we're looking for an accurate solution. So we had to think, what was our rise and our run from one point to the other? So going from my purple point to my red point, I'm going up 4 and then over 6. Can I reduce this slope? What did it reduce down to? 2 over 3. So that means I go up 2 over 3, up 2 over 3. And that is my first line. So we need to remember how do we graph slope-intercept, how do we graph standard form. We need to know the difference and know when we have a standard form or when we have a slope-intercept like what we had on the last problem. Because sometimes you might get equations in either form. So we have to remember how to graph both of them. So see if you can take a moment, see if you can try to graph that second one. So if we graph our second line has a point at 1.5 or 1.5, and y equals 2. So we go down 2 over like 1.5. So down 2 over 1.5. Where do our lines touch? Let's keep our hands to ourselves, please, AJ. 3, negative 2. So that is your solution. Once again, it's not just a single value. It's not just the x, or it's not just the y. It's both points on that coordinate. So your last thing to do, see if you can get that last one graphed. Once again, it's standard form. You're going to use your cover-up method. So once you figure it out, find the coordinate. What is the x? What is the y when they cross? So on this problem, let's listen up. On this last problem, what was our solution? What do we find for the coordinate? 3, 2.
Oh, we got it.
2, 0. Remember, something very important. A solution is not just a single number. It is an x and a y. You need both numbers for your solution to be correct. If you just give me one number, that's not right. So I need the x and the y. So 2, 0 is your solution. Tomorrow is our senior citizen luncheon. So I know a lot of you are going to be absent or working with that. That's okay. Once again, if you're here though, and you want to talk about your test from Monday, we can do that tomorrow. On Friday, we're going to continue using this stuff. We're going to continue working and graphing with this. So don't necessarily throw away your papers because you probably might want it for Friday.
Friday test.